Okay, so the same thing is going to be done here. Okay, in this case here, I'm going to have to solve for the third side here. Okay, so I'm going to use Pythagoras, and I'm going to solve for this side c. So in this case here, side c is going to be the longest side, so I can say c squared is equal to 1 squared plus 1 squared. So c squared is equal to 2. So c is equal to plus minus square root 2. Well, I'll just use the square root 2. Now, I would like you to start using exact values, okay, but for now we're going to be okay with using the decimal value of this, which is 1.4, approximately 1.41. Okay, so if you're comfortable with the decimals, go ahead and use the decimals for now, okay, but we will have to use the exact values eventually. Okay, so I'm going to now write a ratio to solve for these two sides. And I'm just going to solve for one of these because we kind of know that these are going to be the same. Okay, this looks like a very familiar triangle. And in fact, I can actually solve for this algebraically by going x squared plus x squared equals 6 squared. But I'm going to use a ratio instead. Okay, so in this case here, I have a hypotenuse here, so I need to involve the hypotenuse in my ratio. So I'm going to solve for, let's say, adjacent to angle A. Okay, so I need to make sure that I know exactly, I name the exact side that I'm going to use. So I'm going to use side 1, and then I'm going to use the hypotenuse, okay, which is square root 2. Okay, I need to make an equivalent comparison in the other triangle. So adjacent angle A is x. Hypotenuse of that triangle is 6. Okay, so when I solve for this, I'm going to cross multiply this. So I get x equals 6 divided by root 2, and that's going to be my answer. Okay, now if you're using decimals, okay, which is not as good as using exact values, but if you were using decimals, 6 divided by 1.41, it's approximately 4 and we'll just round that to 2.5. Okay, so it's about 4.25 is the length of this side. 4.25 approximately. And so if we actually tried to do this out, although it's going to be a little bit off because of our rounding, if we did 4.25 squared, 4.25 squared is 18.1 plus 18.1. Okay, that's going to give me just a little over 36, and this is going to be square root of 36 is going to be 6, which is going to verify this length. Okay, so that triangle works with Pythagoras, so we must have gotten the right answer here with 4.25. Okay, so then we'll do the same thing here. Because of the shape of this triangle, we know this is a 1-to-1 ratio. We kind of know that this is going to be 3. Now, normally we wouldn't, but this is a very familiar triangle to us. And we can see based on the ratio, we don't even have to write some algebra to do this. We can probably just say that's 3.5. And then we can use Pythagoras to find the third side. Now, I'm going to do it slightly differently. I'm going to use that same ratio, adjacent angle A divided by hypotenuse. Okay, so it's going to be 1 over square root 2. And I'm going to call this side y. And I'm going to make the same ratio comparison in this triangle here. So it's going to be adjacent to angle A to side y. And then cross multiplying this, I'm going to solve for y. So I'm going to end up with y is equal to 3.5 times square root 2. Okay, since we're using decimals, we'll just work that out as a decimal value. So 3.5 times square root 2 is going to be about 4.95. I'm going to round that to 4.95. So we're going to say that's approximately 4.95. And again, we could have done Pythagoras now, so this becomes just an option using trig. So if I do 3.5 squared plus 3.5 squared. Okay, I get 24.5, and if I square root that, okay, I get the same answer of 4.949, which is 4.95. So whether I use Pythagoras or trig, I'm going to get the same answer. So I'm using similar triangles here to solve that unknown side. So the last thing here that we're going to talk about here is there is two ways to describe triangles, the shape of triangles, using ratios or using an angle. And in fact, because of the shape of this, the ratio of this, we can kind of guess at what these angles are. In fact, we're not guessing. We know that these angles here are going to be 45 degrees. This forms an 45-degree isosceles triangle. Okay, so this is something that we can do. There's some triangles we can make this conversion between this ratio description of shape to an angle description of shape without very much difficulty. However, if I were to ask you the angle when the ratio is 1 to 2, that's a little bit harder. Okay, most people don't know that. So we're going to need some help with that, and we're going to get the help through our calculator, and that's when our calculator becomes involved. For now, we're going to do trig without our calculators, but some of you may have noticed that there is a button on your calculator that says sine, cos, and tan. Some of you guys know that that is for trigonometry. Okay, so we'll get into that a little bit later. We don't need that right now. We need to know what sine, cos, and tan is first before we start using our calculator.